Everyone, and welcome to this new lecture of Basic Programming and Modeling for Geoscientists. Today, I will introduce you to arrays. So what are arrays? There are different types of arrays. We will talk about vectors, matrices, and n-dimensional arrays. So the first thing we'll discuss in this lecture will be vectors. So once again, I think it's good that when you follow this lecture, you also open a REPL. So the usual within VS Code, you type Ctrl+Shift+P, Julia, start REPL. So one way to imagine an array is to think about the mine tower. So it's a big tower and it's full of people. But you're looking for one specific person, and this person is called Erika Mustermann. And when you reach the tower, if you want to find Erika Mustermann, you should ask yourself, in which floor does Erika Mustermann live? So you need one piece of information to find Erika Mustermann, and that is the floor number. So you know that Erika Mustermann is living on the 10th floor, which is probably somewhere down there, very low in this huge tower. So that's a more schematic way of representing the inhabitants of the tower. So this is like a vertical ladder here. You have different floors. On the 8th floor there's Max Schuster, on the 9th floor there's Herr Windling, on the 10th floor there's Erika Mustermann, and she also has neighbors upstairs, Dr. Clemens and Frau Apfel. So when you want to reach Erika Mustermann, you need one information, and this is the floor number. So in terms of pseudocode, it will look like this. This will be one array that contains different pieces of information, different names of persons, and we will call it the mine tower. This mine tower, it has different floors with different pieces of information, and to access this information we will use the index. So the array mine tower of index position 10, so the index will always be located between square brackets, like here. This is equal to the string Erika Mustermann. So here it is a string for the sake of our exercise, but it could be a double, a floating point number, an integer, a logical number, or anything. So this is the information which is stored at the entry number 10. The index is used to access this of the array mine tower. So a vector is a one-dimensional array. An example of a vector could be in mechanics, for example, could be a velocity vector. So you all know a velocity vector is defined by 3 components. So you have 3 numbers inside a single mathematical object. This is a vector. The vector is generated using square brackets, and the entries are separated by a semicolon. So you can use the REPL to type this. So and generate the vector A equal square brackets 1 semicolon 2 semicolon 6 semicolon 83 semicolon 3 and right square bracket. Then Julia will return to you that you have created a 5 element vector, so 5 element, 1, 2, 3, 4, 5 vector. And it will automatically identify the type, integer 64. None of these numbers have decimals, so they are all integer numbers. So you just define a vector. So the specificity of the vector is that it contains multiple numbers or multiple informations. When you want to access the entry or the information inside the vector, you will use an index. And that's very important. So on this line here, you see the vector itself that contains the numbers. And on the line below, you see the index. So in the position 1 of the vector A, there is the information 1. On the position 2 of vector A, there is information 2. On position 3, there is the information 6. On position 4, 83, and position 5, 3. This is our vector. So in Julia, as in MATLAB, the minimum index will be 1. So indexing will always start with the number 1. So you can try, train yourself and try to access some information. So remember, the vector is here. If you type A square brackets 3, you should access information which is 6. This is the third position in the vector. A of 3 is the third position. A of 1 will be the first. And A of n will be the last. You can also modify the vector using the index. So in this example, now you will access A of 3 and replace the number by another number, here 72. So if you do A position 3 equal 72, then the third entry will be replaced. It will be changed. So you have modified the value by using indexing. So that's very important. When we will be working with arrays, you will be using the index. And the index here, this here, will always be an integer number and a positive integer number. So some useful function that relates to vectors. One which you have already experience with is called zeros. So that's a function that can be used to generate a vector filled with zeros. So if you give this, you can give the size and it will generate a vector. So if we make zeros of 4, you can try it out. Then it will generate automatically a vector with 4 zeros inside, and the default settings is that it will be a floating float 64 type. Then you have the same with ones. You can make ones bracket 3, and then you will get an array with 3 ones inside. But you can also multiply your vector of ones. So if you multiply the vector of ones by an arbitrary number, for example here 56, your vector will contain 3 times 56. If here you set 3000, then you will have a vector with 3000 times 56. So these functions, zeros and ones, they are useful to generate vectors. they basically allocate the memory and they initialize also the value of your vector prior to any computation. So they're very useful functions. They allocate the memory and initialize. So sometimes you may wonder what is the size of your vector. And by size here, I mean size in terms of number of elements. I'm not talking about the size in bytes first. So if you want to know the number of elements of a vector, you can simply use a function called size. So size brackets A will return the size of your vector. So here it's 5, nothing, because it's a one-dimensional array. And the only dimension there is has 5 elements. And yes, it's not to confuse with the function sizeof. Remember, we used sizeof before. Sizeof will return you the size in bytes and not in number of elements. So if you want your data to be represented by a row vector instead of a column vector, you can transpose it. You know the transpose? If you have a vector with 2 elements here, and you apply the transpose of it, then it will be basically rotated by 90 degrees. How to do that? In Julia or in MATLAB, you just type A and you use one tick here. This will generate the object, so it's called a joint with element type int64 here. So you see that now it's been displayed horizontally. And now we need to discuss also some operations we actually already used in the previous exercise, and these are called element-wise mathematical operations. So what is an element-wise operation? It is an operation which is applied to all the entries of a vector. To do an element-wise operator, you will use a dot. So an example of element-wise operator would be the sum of 2 vectors. So if you want to add A and A, you can use the plus sign with a point in front. And if you want to divide all the entries of vector A by all the entries of vector A, you can use the division preceded by a point. Of course, if you divide A by A, all the entries will be equal to 1. So the dot will be very important in the following of the course. So here, what we did just before, multiplying ones of size 3 by a number 56, I use here explicitly a point multiplication because in fact, the number 56, it's a scalar number, but it's being broadcasted to each of the entries of the ones vector. So that's an element-wise operation. Entry number 1 is multiplied by 56, entry number 2 is multiplied by 56, and entry number 3 is also multiplied by 56, which gives us the result 56, 56, and 56. Very basic example. But sometimes you may not want to make an element-wise operation. So for example, if we do some linear algebra, we may sometimes use a scalar product. So you know what a scalar product is. It is the multiplication of the transpose of a vector by a vector, and this multiplication here is a matrix multiplication. So the transpose of vector A with two entries, A1, A2, will look like this, and the vector B is B1, B2. If you do a scalar product, the result will be a scalar, A1 times B1 plus A2 times B2. So you basically you employ vectors and the result is a scalar. So care needs to be taken because these operations are not commutative. You cannot do everything, or every combinations here. So, for example, you cannot multiply A by A without having a dot. You will get something which is called a method error, because the dimension of the product will not be compatible. You can do A transpose A. That's what we did just here. This is the scalar product. That's the result you should obtain. And you can do also A times transpose of A. And now, if you do this, you will generate a matrix. This is an outer product. So the matrix which will have a size of 5 by 5. We will discuss matrix in the next video. So care needs to be taken for the operations, multiplications and divisions are not commutative when you're dealing with vectors. And for this, you need to remember the rule for matrix products. So there is always this rule: if you employ a matrix of size m by n, and you multiply another matrix of size n, O, the result will be a matrix of size m, O. So it's always the inner dimension here that should be equal. This you need to remember from linear algebra. So number of rows, number of columns, and the result is that if you have the number of columns of the left matrix which is equal to the number of rows of the right matrix, then it will work out. So that's it for the 1D arrays or the vectors, and in the next video I will talk about multidimensional arrays.